I'm going to do a recording about how to produce a spreadsheet to sum 6 concurrent vectors. This is a screenshot of the spreadsheet I already did. So I'm going to delete this and start new so they can do the same. So again, would be for 6 vectors. We're going to input, what's red is input, the magnitude and the angle measured from the x-axis, and then we'll calculate projection over x and y, and then calculate the projection of the resultant, the angle, and then we'll do a polar plot of the vectors and of the resultant. Okay, so we have 1, 2, 3, 4, 5. Actually, Excel can extract your pattern. So if I expand, you'll see 6. So figure out the way I want to generate the sums, and then will be some values I have here. It was f I, the magnitude, and let me make this. I can make this bigger. So fi said, and I want to use subscript. So I go to font and subscript, and then we can make this other like Times New Roman. So Times New Roman, what is it here? And then maybe italic. So I copy this, copy and paste, and then this will be, actually no, this is the angle theta. Theta, I know that symbol is I, or the Q, I'm sorry. So I go and change, just select Q and change it to symbol, and it will turn into a theta. I said I want the I to be subscript, okay, and then we'll calculate FIX. Both of them should be subscripts. Copy, paste, and this is Y. And then I think this is it. Okay, so the magnitudes again, 2, 3, 1, 5, 2, and 2.5. Say I want everything to be centered, and then the angle will be in degrees. So I put the angle in degrees. I can say 20 degrees, 55, 100, 165, say 210, and 300 degrees. Or we can have one that's negative 60 would be this one, 210. Yeah, I can stay 210. All right, so let's calculate the x and y projections. So I'm coloring these in red as my way of showing inputs to spreadsheets. And here I have, so I need to multiply the magnitude of the vector for the x projection with cosine of the angle. So it'll be equals times, and I say cosine, but the number here for the cosine function has to be, or it's expected to be in radians, but I have degrees. So I'm going to say times the angle, but then I say times, let me pay attention here, pi, open close parenthesis, divided by 180, close parenthesis. They might even have, Excel might have functions convert from degrees to radians, I don't know, but this is what I did. Okay, and then I can expand this all the way down. I could repeat the same, but instead I'm just, as you saw, I copied with control insert. Now I do shift insert, and I want to have, instead of cosine, have sine to get the y projection. All right, and expand it all the way down. Now I have these numbers that I want to be, so I go to format cells and number, and I want to have just, let's say 3 decimal places. Okay, so this is really it. I have projections, and the next step would be to evaluate the x and y components of the resultant. So for, let's see, so I can say here r x equals, or I could take this and say copy, paste, so we'll carry the format with it. So I have r, I don't need I, and then I can have an equal sign, and then copy and paste, and this will be ry. Okay, and then what do I have here? For the projection over x-axis of the resultant would be the sum of the projections of the individual vectors functions over x-axis. Okay, and then for the y-axis, it will be sum of the y projections. Okay, so these would be, and I color them blue, would be the resultants, or the rather the projections of the resultant of x and y. For the magnitude of r, it should be, I want to do the copy and paste again to keep the formatting. So this, I don't need a subscript. So how do I get the magnitude of the resultant? I just take the square root of the squares of the components. So it'll be sqrt of this at power 2 plus this at power 2 close parenthesis. All right, so again, this is a resultant. And I want just 3 decimal places. So format cell number 3 decimal places. Okay, so I have the components. A boldface this. I'm concerned more about the magnitude. Okay, and then the last part would be to numerical wise, calculation wise, to get the angle that is measured from the x-axis to the resultant. So this will be arctangent, but I'm going to go with arctangent 2. So it says returns the arctangent of specified x and y coordinates in radians between negative pi and pi, excluding negative pi. If I go with just arctangent, it returns the angle between negative pi over 2 and pi over 2. So I would rather go with this one, and says x number. So I need to take the x projection, put a comma, and then get the, so I'm clicking to bring into the formula the other cell for the projection over y. And now this would be an angle in radians. So to get it into degrees, I need to multiply by 180 and divide by pi. Remember, pi is pi open close parenthesis. So now I'll be in degrees. I say degrees. So units would be degrees. Actually, I can do the same here too, so I can indicate that the angles are in degrees, and I don't want to be italic, so I take that off. I can even just the selection, make it slightly smaller. All right. So yeah, this is for the calculation part. Now I want to do a polar plot, which will be a chart, x and y chart, but showing just segments. So I need to draw multiple lines. That is 6 plus 1, 7. I also want to show the resultant as lines that start at 0, 0 and end at the tip of the vector. So I need the 0 values. Okay, so these will be and I'm using them with all the other ones. So will be common or rather tail point for all these 6 + 1, 7 vectors. So let's see. I'm selecting 0, 0 in this one. Actually, I could start with what? I could start with the. Let's see if it can. It works this way. So I go to Insert in Charts. All charts, and scattered in this one. No, does not work. Cancel. It's a bit confusing to Excel because it's expecting. Let's see now. This and this. Come on, Control. I hold the Control key, and then go to Insert Charts, All charts. Okay, so maybe this one. I don't want this for sure. And then it goes. No, it's not my chart. So I need to undo and move it back. I was trying to do different than I did it before. So yeah, let's put the first vector again. I need to hold the Control key while doing the selection Control, and in Insert Chart, it'll be All charts and scatter, and now this one. And this is my chart, not this one. So I know that I'm expecting this kind of line. Okay. And then I need to add, I don't need the title. I need to add more values. So I select the plot area and then say select data. And you're here seeing here series 1. So I need to add more series. And I'm not sure if this is visible because I'm projecting just the window. So this might be a separate window. Anyway, so one more time, I selected, in case what I'm doing is not visible on the pop-up window, so I select just this area, and then you go and say select data, and then you have the option to add one more series, and you have series name, skip that, and you have series X values. So I'm going to go and select the X value and then hold the Control. So it'll be the second cell, and then the 2X values. And then you go to series Y values, and I hold the Control key. So it'll be this and this for the second point. And then add new, and then series will be 0 and the third point. And then 0 and the third Y value, and then add again, so series 0 and 4, and for the Y value, the 0 for Y, and this one, and then I have add series 0 and 5, yeah, and then 0 and 5. Okay, and then add will be the last of the components. And then, no, what's going on? No, I did something wrong. It was supposed to be series X values. I chose the name. I don't care about naming the series of 0 in this one. And then series Y values, 0 in this one. Okay. And lastly, so the 7th of the series, this will be the resultant. So I have 0 and the X projection of R, and then for Y, 0 and the Y projection. Okay, so now I have them all. The resultant, let's see which one. If I make I make a change, so see which two change. All right. So it changed the first force, and this is the resultant. I think it was 2 before. So this is the resultant, and I want to make it thicker lines. So lines solid width. So 1.5, I take it to so that I know it's the result, and I show it in thicker line. Okay, so this is it. I have a plot. So let's see, they go in what, 1 increments, and this is 1, 2, 3 increments. As long as in Excel you cannot make graphs that are isotropic. That is, if I'm to draw a circle, for example, I need to do some adjustments to really have that circle showing as one and not like an ellipse. So this grid goes in, they are 1 unit by 1 unit. So if I really want to have the vectors drawing on undistorted, I'm adjusting the size of the plot so that the grid is, it looks like a square. Okay, so this is better versus this one, which they are, stretch over the y-axis. I cannot measure angles, or measuring angles on the plot will be was too much an error. So I'm going back to where these appear like squares. So yeah, this is the final correct plot. And if you look at the value in degrees, make this also boldface. So you can tell like 190 degrees and so 129.89, almost 130 degrees. So yeah, it looks correct. Be aware of this. If I change, if I put a negative magnitude, that vector will flip. Which one is this? The blue one. So you will see it moving here, and of course this also reposition itself. So yeah, a negative magnitude mirrors the vector about its own axis. Just FYI, we always assume vectors to have positive magnitudes. Okay, so you're going to label this concurrent vector summation. Is it summation? It might be with double arrow, so I can do a review. Spelling and concurrent, change, summation, change, and everything else is fine. And then somewhere with spreadsheet by, here will be your name. I put my name here. And this was it. And I move it to where? So concurrent vector summation. And I can even underscore it and make it bold-faced. So yeah, don't hesitate to put this little extra effort to make your chart look good and impress the management or your instructor. All right. So, well, I need to save it somewhere, but first stop the recording. It wasn't only 18 minutes, and you can watch it fastest speed.